First of all, let's go over quick some of the data modeling skills that you'll need, right? Just so, to understand the different types of inheritance that JPA supports. Although you might have gone over this if you've done 5200 or some of the or 3200, you might have already done some of this already. But let's see how ORM support class inheritance. So JPA implements three of the main strategies of implementing inheritance in a relational database, right? Relational databases don't have as a concept the idea of inheritance. So we need to be able to map the idea in object-oriented technology. We need to map it down to relational databases. And how do we do that? So there's three basic strategies. There is the joined, single table, and the table per class. And I briefly touched on this a couple of days ago. So let's look at each one. Joined. First, a joined. So joined is the one that I think we would most intuitively capture, right? You would say, well, we have three classes, so you would have three tables. And like the classes, each class has its own set of fields, right? So where the base class has all the fields that are common to everybody else, and then all the specialization classes have their own classes, and somehow we need to inherit from each other. So let's take a look at these couple of classes. So we have a base question, right? The base question you might have capture all the things that are in common to everybody, right? Like they all have IDs, they all have points, they all have a title, a description, instructions. These are all fields are in common to all questions. Yes. Notice that my naming convention is that the real class is base question. I only add a joined after it so that I can distinguish between all three versions. Okay, because we're gonna look at the same exact example, right? But three different ways. Right? Look at the joined, the single table, and the per class. All right. So joined. One other aspect here that is worth pointing out is notice that in JPA you can specify exactly what the name of the table you want to use. Right? If you don't specify it, by default it'll use the name of the class as the name of the table. Right? But here you can specify exactly what you want. And notice that we are specifying what strategy we want to use. By default, if you don't say anything, the default is to use the single table. Right? It'll collapse all the classes and subclasses into one single table. Right? That's the default. Here we're overriding and it says no, we want joined. Right? So we want to have we want to, instead of collapsing everything into one table, we want to instead, if we have these classes inheriting, and this is the base, and this is a true and false, and this is a multi-table, a multiple choice, we want instead a table for each one, right? So we want the true, and so these are records, right? So this will have only fields for the base question, the fields for the true false, the fields for the multiple, and somehow we need to join them together, right? Which is a pain, right? Especially if this is multiple layers of inheritance, right? Joining them is very expensive. But anyway, it would be done for you. JPA would do the joining for you, but you still incur in the performance hit, right? That he needs to join all those tables together. Anyway, so here's the base question. This is a true or false question, right? And notice that it extends the base question joined, right? So it's inheriting the ID, the instructions, the title, it's inheriting all that. It's adding one additional field, one single additional field, just the is true, right? And we are naming the column explicitly. We're calling it is true, and we're saying that it's required. It cannot be null, right? That's optional. You don't have to put that, but we want to know if it's true or false. And then we have the other class, the fill in the blanks. We have an additional. Notice that it's inheriting also from base question, and it's adding an additional field, the variables. It's just it could be a string with variables. Again, you can rename this any which way you want. This is only for illustration purposes. Okay. What else? All right, so these are the 3 tables that are created for you by JPA. Here are the base question, right? Notice that it has all the common fields, right? The ID, the description, instructions, points, title, and the primary key ID. All right, so it's what you would expect. And then each one of the other ones, right? The true, false, and the fill in the blanks. Notice that it has only the field that goes with that particular class, right? Notice that it has is true and variables, only those, right? Presumably, the rest of the information is in the other table, right? So if you want the whole fill in the blank question, right? JPA will join this record with the equivalent record on the other table, and then it will give you one single object, right? Populated from 2 different tables, from 2 different records. Make sense? Right? And that's done for you for free, right? Now the trick here is that you need to have a separate repository for every different table, right? Because when you retrieve a multiple choice or fill in the blank or true and false, right? You want something that is of instantiated as a true or false question, right? Which will be the join of two tables, right? But that will be done for you. But you need the separate repositories, one repository for every single table. Yes? All right. And then, so here's a controller. I'm bringing here all the repositories, every single one of them, right? Because we're going to be using one single REST control for all of them. Well, you could separate it, right? But I took some shortcuts here. I put them all in one single service. So here's an example of trying out what it would look like if we save a base question, only a base question, all by itself. We're not telling it what type you are. It's just a base question, so it doesn't know if it's a true, false, or multiple choice. It doesn't know, right? So all by itself, we're only setting the description, the instructions, the points, the title, and then we're saving it, right? Saving it. So this is going to do an insert into the join base question table, right? It's not going to make an insert into the other 2 tables because it's not of that type, all right? So it makes an insert in there. If we make an insert, if we instead create a fill-in-the-blank question, right? It's going to have the same fields, right, as a normal question, right? The description, the instructions, all those are inherited from the base class, yes? But in addition, it has this one more, right? The set variables, which is for this particular type of question, yes? Right? And then we insert it, we save it. Now this one is going to do 2 inserts, right? It's going to insert half of the fields into the base table, and the other field, the variable, is going to insert it in the other table. See that? It inserts 2 records. And when you retrieve them next time around, if you ask for it by ID, right, it'll do a join on those 2 tables to retrieve and reconstruct this fill-in-the-blank question object. All right? It'll need to do a join. And same thing for the true and false. Right? Say it has the common fields, the description, instructions, but it has this additional set is true. When you save it, it does an insert into the 2 tables, right? And when you retrieve it from the database, it'll do a join from the 2 tables and reconstruct the object. Okay? If you go and fetch these, right? This is what comes back from the database, right? From the base class, we have the instructions, the IDs, and whatnot, the points. And notice that it doesn't have any of the other fields because it's only the base question. If you retrieve the fill in the blanks, it'll have the variables, obviously. And again, this is the join of the 2. And then for the true and false, it'll have the is true additionally. Okay? All right. And this is what the database looks like. We created 3 objects, but there were 5 inserts. Okay? The first one is the base object we just inserted, right? When we didn't tell it what type it was. Right, so that was the first one. And then for each one of the fill in the blank and the true and false, there were 2 inserts for each, right? And so we have here descriptions 2, 3, 4. That's the second one. That's the fill in the blank that we created, right? It was ID number 2, Here is the fill in the blanks number 2, ID number 2. It matches. This 2 matches that 2. Right? They're the same. That's how JPA knows to go fetch them. Right? So if it's an ID 2, it needs to join it with this one, 2. Okay. Same thing when we inserted the true and false. Notice the is true is true, right? And then the 3 matches the 3 with the true false object there. Make sense? All right, and that's how it's going to join them to retrieve them and reinstantiate them. Everybody okay? All right. So this is the strategy that I'm asking you to implement for this assignment. All right. Okay. It's the least efficient implementation. Right. It's the slowest because it needs to join all these tables. All right. Nevertheless, JPA will do this for you automatically. Right? You don't have to join anything. Right? JPA does that for you. The single table, this is a default implementation. Right? This is what we've been kind of doing our own by hand. Okay? But you can also explicitly set it up by saying that you want the inheritance strategy to be single table. And notice that the name of the table, I changed it. Right? Before it was joined base question. Now I'm calling it single base question. All right? So it's a different table. Same thing, the auto increment, its identity. This is the same exact class, other than the name is different, right? And it's mapped to a different table, all right? The other two, the true and false and the multiple choice, these are exactly the same classes as before, right? The only difference is that the names changed, right? And I'm mapping them to a different table. That's the only difference. But the data model is exactly the same. When you create it, right, instead of creating 3 different tables, it creates just one, right, one single table, and it collapses all the fields of the inherited classes, of the derived classes. It collapses them all into one single table. So notice that this is the single base question, right? Notice that it has all the fields of the base class plus the 2 fields from the derived classes as well. See that? With the addition here of the D type. See that? That D type was added by JPA to be able to distinguish later on, right, when you're asking for true false or you're asking for fill in the blanks, it'll know which one it is, right? And some of the fields will be null, right? So if it's a true and false, all the multiple choice and fill in the blanks fields will be null, right? If you're asking for the other ones will be null. So anyway, so if we insert, so I created CRUD repositories for each one. These are identical to the ones before. The only difference is that I changed their names to be single, right? And they're using the new objects, right? The single objects, not the joined objects, right? So they're using a different data model, which actually they're identical to the ones before. I created a service for single, the same identical wiring for the rest. The content is identical. I'll provide all this code for you. The only difference is that they're using the repository, the single repositories, to retrieve back and forth from the database, right? From the REST point of view, right? The client doesn't see this. The client doesn't see any difference, right? It's a JSON object. It's a URL. It doesn't know that you're using one strategy versus another strategy, right? It makes no difference to the client. Same data. But when it gets stored in the database, notice that it's a flat schema, right? There are no 2 tables. There's no need 2, 3, 4 tables. There's no need to join anything, right? This is the most efficient implementation, right? It's the denormalized implementation. So typically, these are the 2 classical ways of implementing them, right? Either the fully normalized or the fully denormalized, okay? Well, there's one additional strategy, right, that kind of has the best of both worlds, right? It has it's called the per class inheritance, which borrows ideas from both strategies, okay? In this strategy, right, the strategy is called table per class. So this is the identical same base question per class that we saw earlier. The difference is the strategy is different. The name is different also, right? But here we are changing this to, instead of identity, to auto, right? Because it's going to have to keep track that the IDs are going to be pushed down to some denormalized tables below, and it's going to make sure that those IDs are the same all the way through. So they're not all going to be auto-incremented, right? They're going to be, as they're being inserted, they say, oh, what did I insert? Oh, that's the new ID. I'll use that same ID later for the other records. So be careful, right? This is not identity. It needs to be auto, right? That's the only difference in the entities. The other two, I didn't copy them, but they're identical to the other ones. I didn't copy them, so all the derived classes, the fill in the blank and the true and false, are inheriting from this one, and they don't change. They're identical. We end up with 3 classes, 3 tables. So just like the normalized version, we end up with 3 tables, right? But then you would say, well, isn't that the slowest, the least efficient, right? Well, no, it's 3 tables, but what it does is that it denormalizes down, right? Instead of denormalizing from the derived classes up to the base class, right? Instead, what it does is that it grabs all the fields, from the base class, and it copies them down, right, to the derived classes. See that? Right. So all these, the description, instructions, point, title, since these are inherited from the base class, it literally, right, copies those fields down here, right? So you get the best of a world of normalization, because you have per one class, one table, right? Folks like to see that organization. You know exactly which table is storing what, right? And also you don't have any wasted space. Right? You don't have any wasted space in the single table. In the single table strategy, you would have a lot of empty spaces, right? You would only have the data for that particular type, but everything else would be null, right? So here you don't have that. You have exactly what you need. This is for the true or false question, and the same thing for the fill in the blanks, right? We're copying all the fields from the base class down to this normalized implementation, plus the specialized field that is for this particular class, right? And so again, there's no need to join, because the data is stored right there, so that you don't need to join, and it's normalized, so it's perfect. Yes?
Is there repetition in the base class, like when you make a fill in the blank? Is that same thing?
No, it's only stored at that particular level. Yep. Yeah. Only if you store a base record, then it only uses that one at the top. Right. Yep. So if we insert, I don't have it here. I think I have it here. So here's the tables where we have the per class. These are okay. I did it twice, so it inserted twice. So that's the base class. This is the fill in the blanks. Right. Again, this is the record for fill in the blanks, and this is the record for the true false. Notice that it has all the fields of the other one plus the additional field for that one particular one. Right. And it's only reproduced at that one record, at that one table. So you get kind of the best of both worlds. Right. So those are the 3 strategies. So yeah, you can use either one, either the normalized, the joined, which is the most expensive, the slowest, but yet I think it's one of the easier to understand, or this one. Right? Either one will be fine, just not the single table, right? Because that we did for the previous assignment. All right, excellent. Let's keep going.